Now that John's woken you up, hopefully we'll try not to put you back to sleep. My name is Arvind, and this is Amit, my colleague. We're from Oracle, and we'll be talking to you about Oracle's take on the serverless world. Before we get started, the usual safe harbor statement, which basically means that don't make any purchasing decisions based on what you hear today. So serverless is the hot new buzz for making it easier for developers to program for the cloud. And in this session, we're going to talk about some general concepts of serverless, the serverless platform, and then we'll move on to the exciting new technology that Oracle open sourced a couple of weeks ago as a contribution to the serverless community. And then we'll use that technology to build a scalable, reliable app from the ground up, and hopefully the demo gods willing, all that goes through without any glitches. So as Srushit already said, serverless doesn't mean that there are no servers. There's lots of hardware behind the scenes. There's networking gear, there's load balancers. It's just that the serverless model is aimed at making it easier for developers not to have to think about infrastructure and just to focus on developing business logic that solves problems. At the heart of a serverless architecture is a FaaS platform. The functions is a service platform. A function is a simple piece of code that does one thing and does it well. And in the serverless world, you deploy a function as a unit to the platform, and then the platform takes care of finding a VM based on maybe what language you programmed the function in, and auto-scaling it based on request load to that function, and all the other tricky things like security, billing, authentication, logging, debugging. The platform takes care of that for you so that you as a developer don't have to worry about those things. And it has to do all this at huge scale. It has to do it fast, and it has to do it as a price point that is attractive to both the end users as well as to the cloud providers. So the focus of serverless computing is code. So developers only focus on splitting their application into small, simple functions. And this makes it easier for developers to manage their functions, to debug their functions if they're all deployed as simple units. Just having functions alone and being able to deploy them into a platform isn't very useful. You need to be able to stitch the functions together in a way that solves a real problem for a customer. And we'll talk about this later in the talk, where we demonstrate how Oracle's open source technology can be used to do this. So the serverless platform, the FaaS platform, has to be able to handle any load, as Srushit already said, whether it's a regular load during your normal business hours, or whether it's peak loads during the holiday season, or your app going viral. It has to scale organically without you as a developer having to worry about what you need to do in order to make your function scale. The serverless deploying functions as a service and using a serverless model also brings quite a big change to the billing and the cost. The first thing is you don't pay for anything that you're not running. So you only pay when your function is running. You don't pay when it's not invoked, which is different from the way you deploy stuff to the cloud and your server's consuming resources, you're still paying for it. The other change is that in the serverless model, there is sub-second billing. So you typically bill in 100 millisecond increments. And because of this, developers focus on just their functions, and that makes it easier to produce better programs that do things that customers want, rather than having developers to worry about what the cost of the, running the infrastructure and the scaling is. From a cloud provider perspective, they can pack more functions into a single virtual machine or a single piece of hardware, and so their price performance, their price point is good, so they can pass on the benefits to customers. The complexity of auto scaling, billing, logging, authorization is moved into the platform, and every app developer doesn't have to worry about the specific things they have to do for individual applications. The platform takes care of that for you. So the combination of all of these things, we feel that this will change the way people think about software development, because when you're using libraries, you'll automatically start using libraries that are small and run fast, so that you're not paying for long-running functions. And this will improve software engineering discipline as more and more people switch over to a functions as a service platform. Sorry. What happened here?
It's gone?
Okay. So the ideal functions platform, we feel, like you said, it's open source, so you can run it. You have full access to it, to what it does, so you can sort of tweak it to your needs if you need to. It can run on any cloud platform. You should be able to program in any language of your choice. Container-based, and you should be able to use any orchestration tool like Kubernetes or Swarm. Excuse me. So that brings us to the exciting new project that Oracle open sourced during Oracle Open World a couple of weeks ago. The FN projects, that's the website. It's an Apache 2.0 licensed project. It's completely open source. There is no proprietary code that Oracle is withholding. What you see in GitHub, what you see in the project website is what you would run on your laptop, and what any provider like Oracle would run if they were offering this as a managed service in the cloud, which is slated for the near future. And this allows you as developers to get involved in contributing to how you would like to see a serverless platform evolve. So in the FN project, there's awesome Java support. The Java support specifically, there's a built-in JUnit-based testing framework. So to provide a high-fidelity testing environment in your local machine, and it's the same thing that would be used when you deploy your function to the production environment, so you have a good confidence in what you're deploying, that it's doing what you expect it to do. There's also some APIs to access configurations and secrets that you can use in your FAS code. And it's a type-safe way. It takes advantage of Java's type-safe capabilities to provide a programming model that you're familiar with if you're a Java developer. This doesn't mean that it only supports Java. Out of the box, I think there's support for about 15 different languages, and more are on the way. The nice thing about the FN project is that it's Docker-based, so if you can take any of the Docker containers and leverage it in your FN system. And along with the FN project, one of the components is FN Flow. What I talked about earlier is you need a way to stitch functions together to orchestrate to actually solve a business problem. And we'll talk about this a little later on. So let's take a look at take FN for a test drive, and I'm going to turn it over to Amit, who will show you.
All right. Good morning, everyone. Of course, before we get started with some of the demos that I will be doing, just wanted to get a pulse among the audience. Anybody heard about Function Project or used it? It's fairly new. We just announced it a couple of weeks ago. Okay, there are a few people. All right. So my aim here is to walk you through this function platform. I will be doing a series of demos, small demos, to help you understand the platform better. The first thing first is that we will be I will be creating a sample Java function for you from scratch. I will create a directory and I will do it from scratch. So you'll get a feel of how easy it is to actually get started with the function platform. So for you to get started with the function platform or function project, what you need to do at a minimum is to download a function CLI. The function CLI, you can get it from functionproject.io. And once you have that function CLI, you will have to start the function server. Now, there are a few things to note about this function server. I hope you guys can see the command that I executed. Is it clear on the backside? People can see it? I'm not sure. Okay. Okay, so the function start that I just executed, this is actually a local development server that you get. This is started on your laptop right now. Of course, this is the same server that will be running on our cloud service, or you can run this development server. It starts on your laptop. This is the same server that you run on. You can run on any of the cloud vendors of your choice. It'll also run in our cloud service that we plan to offer. And this is the first-class server. The experience that you get while you're doing the local development on your laptop is essentially the same as you're doing this on cloud. Okay, enough of talking. Let's see something's in action here. So what I'm going to do is that I am going to start from scratch. I'm just creating a directory here. And the way you get started is you have to invoke something called function init, and you have to specify the runtime that you need for your function. Of course, as Arvind mentioned, there are a lot of choices that you have, but I'll go with Java because that's a language at least I love, and I hope a lot of you have experience with Java. So now there are two things to notice here. I don't know if you can read it. So the function init has created two things for you. One is some boilerplate code for you, Java code. We'll see that in a moment. And a function.yaml file. This is the YAML file that function platform actually reads and know about the function that you're writing. So I'll just quickly walk you through this function YAML. So there are two things to note here. One is the runtime. This tells the platform as to what your function is written in, and the entry point of the function. And when you invoke the function, this is the entry point that will get executed. Okay, we all love code, right? Let's see what happens here. So the demo just showed up. So there are two main things that function init has done it for us. It has written a sample code, and this is a Java code, as you know, right? Now, this is the entry function that we have, and it returns a hello world. It's a very simple function. Of course, you could do whatever you want here. And the other thing is the unit test. So out of the box, we have support for unit testing for Java. And this gives you an ability to run the tests locally, make sure that functions that you have written are written in a way that you wanted before you actually deploy into the production or any cloud. Point for us, this is the function entry point, and right now it does a pretty simple thing. It just returns the hello world or the input that you provide. And of course, now the way you get started with this is to deploy this function. So you could. Oh yeah. Oh sorry. Yeah. So another thing that you will probably have to do is that there's a concept called named app. So app is basically a collection of functions. So you have various functions. You want to organize those functions. So you create something called app. So the way you do it is just give any name. I'm going to give it a name demo. Okay, it's already there, so we're okay here. Now what I will do is I'll deploy the function that we just wrote.
Demo.
Sorry. Demo and the function, right? So, oops. What happened? Oh, sorry. I'm sorry. So, so basically, what we are doing right now is we're deploying this function onto the local server. So you have to say local, and it will build the app and it will publish it to the server that we just deployed. Now, there are two ways you can execute this function. of course. Now, FN CLI itself, you can invoke and execute this function, and the function will execute, and we'll see probably the hello world if everything works as expected. So let me do that first. So you say, so if everything is okay, we will see a hello world right here. So the function is working, as you see. Now there's other thing that you could do. The function platform has a very lightweight HTTP gateway, and it exposes the HTTP endpoint for every function that you deploy. Now the way you could see that is doing a list. Okay, it has deployed more, but as you could see that there are. Okay, this is what we are interested at. We have more functions deployed already, but this is what we are interested at. So what we could do is that we can use our favorite curl and execute this function. So as you see, it returns the same thing pretty much. So how difficult easy it was? Pardon me? Yes, it is using containers behind. So the functional platform is built on containers, Docker. Pardon me? Whatever function is written, that function is your function, right? No, it's all open source. Nothing is proprietary here. Everything is open source. Right. No, so this is our way of doing things, of course. But I mean, what we are trying to say is that it's not proprietary. It's open. The entire project is open source. We probably can show them also. But you could see that the entire source code is open source. The whole servers are written. What command lines are there? Everything is open source. Sorry. Yeah.
So bringing up a container takes time. Bringing up a container takes time.
Not anymore. That was. I'm working on an 8 GB RAM. It's pretty fast, as you saw. I just did it just in front of you.
So that is the FAS platform. Everything is deployed, every function is deployed in its container. There is support for hot functions, so you can keep functions running around for a long time. So again, in the func.yaml, which the deployment descriptor, you specify something that makes sure that the container hangs around and then subsequent requests go to it. Yeah, we'll show it. You can see that later.
And anyway, unfortunately, we have only 40 minutes. I understand you guys have questions. We'll take your question. Can you please hold on? We have a lot to cover, unfortunately. We also have a demo, and we'll be around, so you can ask us questions after the session also. We will take a few questions for sure. I know you guys have questions. Okay. How do you? Yeah, so this actually will work on any of the orchestrators. Right. That's how it would be. It's a Docker image, so you can actually work with the Kubernetes. Because Kubernetes works with the Docker engine very easily. We can actually share you the links. You can go through them, and you have questions, you can get back to us. But it's all possible. That's all I'm trying to say. Okay, I can take one last question from that gentleman there. He raised his hand.
Yeah, the whole point is to be able to write code and be able to call it without knowing what's behind the scenes, right? So from that perspective, am I right if I say that I write code which calls the functions that you deploy in these containers, and then the func.yaml is what kind of connects?
Right.
Cool.
Right.
Thanks.
See, now, what I was actually going to tell you is that the Java function that you see right here, if you have noticed, we are not importing anything special here. This is a Java that you love and know, right? You can write anything here. No dependency of any learning new frameworks. So you write your code, you write your logic here. The only glue that you have with function server is using the function CLI, the way you deploy this to the platform, right? But this code has no dependency. You write your apps the way you're writing it today, no difference.
But there are packages publicly. If somebody has created those packages to support this function.
Which package?
So when you run any serverless, there are supporting packages.
No, we will talk about it. So our platform also have a FTK.
Yeah.
Okay.
So if you don't have a Java FTK, you don't run Java, right?
No, but as you
You
see,
are built, that's why you can run Java, right? If
right. No,
let's
but
say
I'm
you want to know Node.js, you can run that. But let's say you want to run some other technology like .NET,
Uh-huh.
you want to run.
so we support some of them already.
Yeah, I'm saying almost you don't import here, but then you have those packages as part of your the packages of the serverless.
Yes, yes. So
It's not vanishing; it's there. I think I have a question. So you
can
have
we actually we're running out
Yeah,
of time. We have a lot to
I
cover,
wouldn't
so can
honestly,
we
I wouldn't be
take-
able to
yeah.
cover any of this.
No problem.
So we can take the questions a little later if you guys don't
I think
mind.
we'll hold all questions till the end and just go.
Yeah,
go
because
through.
otherwise, honestly, I wouldn't be able to cover half of it, of what we wanted to show today. But we'll take the questions towards the end. If you can, guys can please hold on. Okay, so there is this function that we wrote, no dependencies, no framework learnings, Java, you write Javas. We have a function FTK, we'll show you how to use it and where it's useful. But as it stands today, you don't have to do anything special here. You write the function Java code and it deploys, it runs, right? Okay, let's get back.
Yeah. So now, let's say we're a travel agent. We need to book a flight, a hotel, a car for a customer. So that's the app we're going to try and build. And because we partnered with different service providers for each of these portals, we have a Java API that our flight provider requires us to use. They have a Ruby API that the hotel provider asks us to use, and the car rental has there's Node.js and there's JSON as well. So we have to interface with all these different providers and have our functions as a service invoke their APIs to actually book a car, book a hotel, and book a flight. So I'll take a look at the flight function first.
All right, so of course, this we are not going to write from scratch because we want to save some time here, but we will show you what we have done. So we have a flight booking function which will let you book the flights. Now, okay, so I don't think so you can see everything, but the thing to notice here is that we have some pieces of code which is commented out, which will uncomment as we go along, because we would want to show you a little more of functionality of the entire, travel agent app. But we'll do it in steps so that you understand this clearly. Now, the way we have designed our flight booking function is it takes a JSON input, right? It takes departure time and flight code, let's say. It's a very simple example. In real world, it'll take, of course, much more, probably the input parameters. And the way it works in Java side of things is that you have to write some POJOs like what we have done, right? And the platform automatically maps the JSON to the POJOs. And the platform uses something called JSON underneath for doing that mapping. But the platform is very flexible enough for you to extend it and use the parsers of your choice. So you can potentially work with any input format of what you want, right? So this is how the mapping would be done. Now, this is our entry point function, if you can see it, book, right? The book takes the POJOs that we have defined. And right now, as you see, it just returns some hard-coded confirmation code, right? Now, we'll just run this to see if things are, I'm sorry. So we'll go to flight book here. So we'll deploy it as usual, like what we did. Now we are using a different app name for this because it's travel-related app, so we want to use more logical name. And as you see, this is built it. Now I'll show you a sample payload that we are going to actually pass it to this function. Now, as you see, this match to the POJO that I just showed you in the Java code. It just maps it seamlessly. And what you would do to call the function is that you provide this input. Of course, you can do all this via the HTTP endpoint that we explained it to you, but we can use a function CLI also to just test. So you could all right, so this. If everything is fine, you'd see a confirmation code that was there in the Java code, right? All right, but let's do a little more, real mapping to a real scenario. We will not, of course, return the hard-coded value. So we'll start to integrate with the provider. Now, this provider, we have written it ourselves just for the simulation. Of course, in the demo, we really don't want to book flights, right? It's going to be way too expensive. So we're just going to, we have simulated it. There are some fake APIs that we have written, and we'll integrate with that provider. But the capability that we want to show here is that this provider is a third party. You can treat this as a third party, a provider that you have to integrate it with. So the way you integrate it is no different in Java, and you have the APIs, and you just enable the APIs and you work with them. Of course, these have to be in the class path and everything. But so I'm enabling this provider, and I am going to also return, I'm also going to connect to the provider API now. We'll not return the hard-coded value. Okay, let me save this, quickly go back.
Do you have to uncomment the configuration also?
Not yet. Okay. Not yet, right? So, okay, so we will, or maybe because we don't have a lot of time, I will also uncomment the configuration right away. So the idea is that this provider that we have, it takes some additional configuration parameters that you can see it here. It takes some URL, it takes some let's say secret for authentication and so on, and you have to pass those parameters to the provider, right? Now the way it works, this is where the function FTK comes into picture now. So this is the first thing that you would notice about. This is the annotation that is from the function FTK. Now, this annotation tells you that this is a configuration, and it will run only once at the beginning of the function invocation. And once it runs, it'll read this configuration parameters. Of course, the question would be how you pass this, and that we'll talk about it. But essentially, it would read this configuration parameters and pass it to the third-party provider. All right. Okay. Now, here is the catchy part. Now, we will anyway deploy this to begin with. All right. So it's deployed. Now, the providers that we have to start them. This is our own providers. They are not running anywhere right now. So we would have to start this providers. We have written a script. These providers are also Docker containers, just for the demo. So it's start a bunch of providers. Now, the provider API would connect to these containers to just do the bookings and so on. And just quickly to show you if this works. This is our provider dashboard. This is external dashboard. It'll tell you, okay, have you booked a flight and hotel and so on, right? All right, so far so good. Now, we'll have to, as I said, this function now requires additional configuration, right? Now, how do we pass this configuration? There are two ways. I'll show you both of the ways here. Okay, first let me.
Amit, you have 9 minutes.
Oh, sorry.
Yeah.
I'll just do it quickly. All right. So I will. So there is this function CLI. You can actually set the secret. This is one of the secrets that it needed, as I showed you in the code. So this is how you set it. And the other way you can do it is also specify in the YAML file. All right. There are two ways to do it. You feel free to choose whatever you feel easier, but you can pass the configuration like this. Now, since it's all set, we would just execute our. We'll just execute our app, right? A function. Now, as you see, the code that is written is different. So this is coming from the provider. Now, you will see that provider has received that request. So this dashboard actually works that way. All right, let me quickly switch back to the browser.
Okay, so I'm just going to go, we have about 8 minutes left, so I'm going to click through some of the other slides and we'll come back to them. So similar to the flight booking app, we can now deploy all the other apps. I'm going to ask Amit to do it, and then while I talk through the rest of the stuff, then when we come back to it, we can look at that.
Okay, so other providers, they are written in different languages. Since we don't have time, I'm actually not going to go to the code at all. but they're written in different languages, Ruby, Node.js, the language of your choice. And I'm going to actually deploy all of them in one shot. Let me see if I'm in the right directory. Okay, so as you see that I have all this various functions right here written already. So the way you can deploy that in one shot is you can say all. So what it essentially does is it scans the folder, it'll look for function.yamls, and it'll know that this function is to be registered. And it takes a little while. Hopefully, if things are okay, it'll be quick, because it's scanning everything pretty much, right? So if this works, okay, that was not bad. All right, so now we'll see that all this travel app has the HTTP endpoints, and you have all the functions already registered here. You can invoke them. It will work like what we have demonstrated. So I'm not going to go to that, because we have other important demo to showcase to you pretty shortly. Sorry.
So we'll move to the trip booking function. So this is the one that stitches different functions together. And this is not a problem that's unique to the serverless world. If you have a bunch of functions that you need to call, you either have a choice of writing one big blocking function that invokes one after the other. So you book the flight, you book the car, you book the hotel. And that defeats the purpose of serverless, because the orchestration function is blocking for the entire time, and you're paying for that. The other way is to have the flight booking function call the hotel after it's done, and the hotel call the car. And that has the disadvantage of all the upstream functions need to know what the downstreams are. And the solutions have been to express this form of composition of functions in different languages like BEPL or XML or JSON. Not every problem can be expressed as a state machine, so it's difficult to map it. When you have to add error handling into the different, at each stage of orchestration, if you need to add error handling, then your code quickly becomes complex. Testing is difficult when you have a distributed system with a lot of functions. Debugging is equally, hard. And then you end up having to write this whole orchestration service, and then you end up having to manage it. If you're going to feed data taken from one function into the other, you need to write a lot of glue code to extract just the data that you need from the response of the first function into the second one. And then if you have a different language that you need to write the stitching function in, then that means you as a developer have to learn something else that you're not used to. So that's where FNFlow comes in. FNFlow builds upon the completion stage API that was introduced in Java 8. So this is a futures promise kind of API, and it uses this type-safe API and you can use this to implement your flow. And so that's what we look at in the rest of this. This is the last section of the presentation, and.
All right, so function flow, right? Now, this is where the FTK comes in. This is supported by the platform. This is unique to us. And as Arvind mentioned, we intend to solve the problems of where you have a lot of functions and you want to change them, you want to deal with the output of those functions, and you want to do something useful about them, right? Now, that's where this helps. And I'll just quickly show you how it looks. So we have something called trip. And okay, you guys can see it, right? Okay. Now, all right. So this is now so there's some understanding that you have to do, because it's a new concept, of course. But we feel that it's useful, and you would really like it because it will solve a lot of complex problems for you while you're doing the code. Now, each function that we have, it runs in a context of something called flow. This is what I'm talking about. This is our API. And when you invoke a function on the flow, you get something called future flow, right? Now, when you get the future flow, Now, future flow gives you a lot of constructs, right, to chain functions. Like what we have done, we are using something called then compose. You can do a lot more things. But once you get the future flow, you can chain the functions. You can use then compose, and then you can chain functions like this, as you see. So we are chaining flight booking, hotel booking, and car booking right here, right? And of course, now you have booked this. We want to do something useful with it, right? Now, we need to know when the entire sequence of functions will be invoked and successful, and we want to do something about it, right? Now, what we are doing in this demo is we're going to send a mail. And the interesting thing to know about is that when you chain the functions, you pass all these variables that you see here will store the output of each of this function. By the way, all this is running asynchronously. You're not blocked, right? The platform is doing it on your behalf. Now, once you have everything executed successfully, you have all this here, so you can do whatever you want, right? Now, how this works and there are a few interesting things that we'll show you around this. One is that, okay, let me go to the trip function. Oops, sorry. Now, we'll do the usual thing that I guess you guys got a hang of it by now. We'll deploy the application. Not do all is not required. This is only single application. Now, it deployed, right? Now, this is how the JSON sample looks like. Now, you have 3 functions chained up, right? Now, you have to specify all of them here in one go. And this chaining helps you to do all this in one go, right? In the single JSON file. Now, you could execute this function. 1 minute. Oh, sorry. Okay, I have to do this fast. Okay, travel and trip. All right. Now, if you notice, the interesting thing is that this has come out immediately, right? And this dashboard, you would see that the requests are actually landing here. And the email also has been sent, as you see, on the success. So this chaining, that's how the chaining works, right? Now, when everything is complete, the email has been sent here. And you have all the confirmation, all the data that we have, that function invoked, and we passed into the send email confirmation. I think that's pretty much it.
You want to show the UI?
Okay, oh, all right, yeah, I can. Okay, there's another interesting project that we have done as part of the function platform. We have something called function flow UI. Now, of course, when you have a lot of functions, you want to also have some sort of visualization around how this entire thing works, right? It gets complicated over time. Now, we have something called function flow, and if I execute this again, now you can see this is real time, right? It's telling you the flow, what is happening in terms of flow, right? Now, of course, this UI is experimental. We're still developing it. But the idea is that to give you a visualization. We'll also show you when something fails. We'll simulate a failure pretty soon. We'll show you when something fails, how you can debug this, what happens, right? We want to go to the presentation? Not. Okay, I guess the time is up. All right. Okay. So anyway, as you said so far, the recap is that it's just Java. We haven't done anything funky. Of course, we use function flow, but that was very specific to our FDK, but you could do a lot of useful things, right? We need a couple of, maybe 5 more minutes. We should hopefully wrap this up pretty quickly. I actually wanted to show you one more useful thing. Of course, the real-time scenario is that your things will fail. Things don't really work all the time. You have to have your app truly fault tolerant, right? You want to handle errors. Now imagine if you have to write all this code yourself, if else, non-blocking, capture the output, do something useful about it. It's going to be a bit of a pain, right? Writing all that code. So that's why this function flow is in place. Now, so I'm just going to uncomment this. Unfortunately, we don't have time to show you a lot more things, but okay, see, the interesting thing to note here is that the future flow that I was talking to you about, that helps you to chain the functions. It also helps you to handle the exceptions. There's something called exceptionally compose, right? Now, what would happen is that when something something fails, this will be called, of course. The platform will call it, and you can do whatever you feel like. Right now, pardon me? 5 more minutes? Okay. 5 more, that's all. Okay, so we are doing the cancellation of the transaction right now, right? You can do whatever you would feel like, and I'll quickly build this. Okay, I'll quickly run this. Now, okay, nothing will happen right now because we haven't simulated an error. Everything is good right now, right? What we will do is that we will, let's say, fake, not cancel. We'll probably fail the booking system here. We're just faking it right now. Basically, it returns a failure. Now, I'll execute this thing again. Okay, let me clear this up quickly so that it's easier for you to see. Now, I'm running this again. Now, you would see flight is successful, hotel is successful, the car will fail. Now, as a result of that, we'll cancel the transaction. We're deleting flight, hotel, and car, right? Using the exceptionally composed that you just saw. Okay, now, given that I'm going to borrow a couple of more minutes from him, so of course I just wanted to show you the function flow UI also, so that I can actually show you how this looks like when the flow is happening, the live flow. Now, this is happening, everything is working, hotel is working, flight is working, car will fail as we know. Okay. You click on this. What you see here is that car has failed. You have entire stack trace. Do you guys like the stack traces? I'm sure, right? Now you have the stack traces right here. Now, not only do you see the stack traces here, you also see the flow. You see what caused that the call trace. What happened, the entire flow is depicted here. So you can actually trace this problem pretty easily. So we feel that this kind of UI will give you a lot more opportunity to debug the problems that we see in the real time, right? Okay, I had one more thing, so I'm not going to do it, but we also wanted to demonstrate you, as we planned, is to also do a retry. For instance, in the real world, let's say the entire card provider is down, right? The cancel can also not happen. But you would want to retry, maybe it'll come back in future, in some time, right? So our platform supports that too, but unfortunately, due to the time, we cannot do that right now. So that's all, I guess.
What you showed you was Java. There's also stuff for other languages. You can use FNflow. It gives you a good monitoring and debugging tool as well. All the information is on this website. There's a Slack channel there that we encourage all of you to join and contribute. For startups here, Oracle has a startup accelerator program, and the accelerator program provides a lot of benefits for entrepreneurs. There's cloud credits, there's mentoring, and there's co-working space. If you have questions about it, our people are there at the booth outside. They'll be more than happy to talk to you. And at the booth, you can also sign up for free cloud credits. So please do visit us at the booth and come and talk to us. Thank you.
Thank you, guys.